All right. So, shouldn't have been any super big surprises on this test. For one thing, blatantly told you guys a handful of things as we were going through conversationally. Hey, this is going to be on the test. Just straight up told you. People, when they ask me or email me, kind of always feel like they got shortchanged when they say, "Oh, we're going to have some sort of study guide, or how are we going to review for the test?" And I say, "Your PowerPoints are your best bet." And they're like, "Nah," because they wanted a single piece of paper with things boiled down on it and so on and so forth. The thing is that the PowerPoint is already distilled from the chapters. It's already boiled down. And I don't want to say that, each and every single slide is on the test, so to speak, but they're all related. So I sort of stand by that really is your best method of review and or prep is looking at those. And arguably many of the questions are straight off of the handouts. So if you did not utilize those for the first test, okay, I strongly recommend it for number 2. Also to that end, all right, if your first grade wasn't exactly what you were hoping for, I didn't look at your guys yet. I don't know what the distribution was. I'll be honest. But there's always some people, did really good, and some people didn't do so good, and a handful of people in the middle. Hardly ever you get this truly bimodal of everybody gets it and everybody doesn't get it. There's always that bell curve, so to speak. A first test in any class is a learning curve, okay? How does the teacher write tests? To what depth do they worry about stuff, so on and so forth? Did they lie to you and it's really just straight out of the book? All that stuff, okay? But you add into that perhaps your first science test in college, and they're different critters. It's if you've had a math class, a history class, you know that they all have different kinds of tests, so to speak, okay? And science is no different to that. Arguably and regrettably, as I said, we don't get a whole lot of opportunity to get beyond the vocabulary word level in here. There are a few times we get to apply some knowledge. And one of them I never really even noticed it. It was sort of so embedded that it skated right by me. But this morning we were going over, I told you I start all my classes more or less with the same handful of topics. So we were going over that atomic stuff. And really, some of the questions were predicated on you knowing what the previous, question, the correct answer to that one. If you didn't know that the atomic number was the number of protons, for example, and the number of protons makes the element, then you wouldn't have a freaking clue when we got to talking about an isotope as to why you can't change protons, why it has to be neutrons. And again, I've been saying it, 20 times, for 20 years I've been talking about it, so maybe that stuff is, like I said, just kind of glazes over for me. But that does build. That's building knowledge. So I shouldn't discount, I guess is what I'm saying. I shouldn't just discount these as vocabulary words, because they are connected in many cases. We don't hop around quite as much in here as we do in geology. Geology, we've got volcanoes. Okay, now let's talk about earthquakes. Okay, now let's talk about sedimentary rocks. Now it's all over the place. You guys, at least, we've got some common themes. So that's nice. That's an opportunity to build. But again, if you don't get the basics down, you don't get the fundamentals down, you're not going to build a very stable structure. Not to get all metaphorical and crap, but so the stuff in the beginning, going to stick with you, hopefully. All righty. And this is also goes a lot smoother and or slightly more interesting if you guys actually respond. instead of me just saying, it's this, it's this, it's this. So, word science comes from which of those? Huh? C. C's not an answer. What is the word?
To know.
To know. Good. Good. Science supposedly means to know. All right. Someone picked inform a little in the last class, and they weren't exactly arguing with me, but I could tell they were a little grumpy because inform is close to know. It's telling knowledge and so on and so forth. But we're talking about the root word here, the etymology of it, so on and so forth. And this is, again, where if you guys are with me in class, you can come up and say, okay, hey, I know this means this and this means that, but which one are you? And I won't always be able to answer your question, but at least half the time I can. All right, there are no truths in science because what? Scientists can't be trusted? Seems to be where we are nowadays. No? How about C? C's not an answer, I know. What is accepted as truth could change, right? This is building on the idea of the scientific method. There are no truths. There's no constants, so to speak. And I know, again, physics and chemistry will say, Agrabado's number is. And sure. But we're thinking a little bigger. We're looking a little bigger than that. None of these have all of the steps in them. The one that most closely approaches it, I think, is D. Idea, research, hypothesis, experiment, theory. What did I leave out of D? Well, that's idea. Good, though. Did I don't think I put... Yeah, I didn't put question in any of those there. But idea, and I should change that. You're right. I do talk about the question in lab, or in lecture. I shouldn't change it to idea there. What else is missing, though? Analyze. Yeah, that's in the research and the experiment where you can analyze there. But the steps that we gave you in class, and I said analyze data. Yeah, that's the reason. Okay, all right. So I'm going to rewrite this question. Thanks, guys. What step in the method is truly missing, though, here? Sorry. 3-letter word. Last step. Blah. Yeah. That's the one that's missing. And thank you guys for pointing that out. Nobody's ever, again, in 22 years, no one has said, well, you use different words than you do in the... Not my intention. Okay. These two questions are post-COVID kind of questions. Arguably, they could have, should have been included all along. We talked a little bit about how the general public was exposed to science for the first time and was kind of shaken by watching the process. So I try to get across to you guys so when you go out in the real world, you can be a sense of a voice of reason and calming instead of adding to the chaos and saying, no. Science isn't a lickety-split, quick, bing-bang process. Science takes time. Okay? You don't necessarily need to say slow and laborious. People will look at you weirdly, especially if you say laborious. But it's not a quick process. Okay? And because of that, ideas and thoughts are dynamic and evolving. Things change. All right? That is the nature of the beast. That is why we science. Okay? It's because every time we get new tools, it's really, and I didn't get into it so much this year, in any of the times I gave this lecture, it's really so closely tied to technologies. We get better tools. We see more detail, so to speak. And sometimes that detail really changes the way we think about something. On to the atomic stuff. Okay? I'm not judging, but I'm pretty damn sure that at least half the folks in my geology class did not watch this lecture online. This was the day I was out, and I told you guys you got to watch this lecture. I don't know if you did or you didn't. As I said, I didn't look at your tests yet, but I'm pretty sure a good bit of them did not, because you should not be missing these questions. Literally in the lecture, I said, okay, these 9 things are going to be on the test. And 6 out of the 9 showed up. And this is on the, and this is on the, and they missed them. So hopefully you guys were good and you actually listened to the lecture. Or you happen to just retain this knowledge from like 7th grade, who knows, maybe. All right, significant mass. There's a reason that significant is in quotes there, and it's because of the next question that has no significant mass. Everything has mass or it isn't matter, right? In order to be a matter, you have to have mass. But some matter is so incredibly tiny that when you want to talk about how much they actually add to the weight of something, misusing the word, but it's so tiny it doesn't really matter. It happens to matter in other realms and aspects, but not with regard to that one. So anyhow, significant mass, what are we talking about out of those options? Protons and neutrons, yeah, okay? Both protons and neutrons. This is the beginning of another problem for a lot of students. You're in a rush, you're in a hurry, you're worried you won't have enough time. I get it, but you've been being told for 12 years now, at least, to always read all the answers, right? You stop at the first right answer, you might miss something else. I'm one of those jerks that does that a lot. Again, learning how teachers write questions. If you stop at the first right answer, 50% of the time, just guessing, never actually took data, 50% of the time, there's probably a second right answer in there and both, blah, 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 or all of the above, well, one of those things, okay? Please read all the answers, because if you knew about neutrons and you just started, you're like, okay, good, and you also knew about protons, but you grabbed neutrons and moved on, you didn't even read the rest of the answers, well, you got it wrong, and that stinks, I agree. So please, always look for that down at the bottom, okay? So who's got no significant mass? Electrons, yeah. Don't tell them they don't matter. They matter, of course. There's some really bad physics jokes in there. But yeah, the electrons. Certainly matters for the charge, right? Where do the protons and neutrons live? In the nucleus. It's not a question for some reason. It evaporated somehow. Where do the electrons live?
Outside.
Yeah, depending on your level of chemistry knowledge, you either know the shells, right? 1s2, 2s2, 2p cell, that one fun stuff. Or in here we talk about the fuzzy cloud of electrons on the outside, okay? This actually could have probably gone up to 75 questions, which is probably why a handful got dropped out over the years. But I definitely had more questions about this atomic review stuff. All right, so I was talking about this as we were booting up the test here. If you didn't know that the atomic, is it mass or number, it tells you the protons? Number. Okay, if you didn't know, that's what makes an element, is its number of protons. Hydrogen, helium, lithium, beryllium, boron, or however it goes. I get lost after like 3 or 4. You're just adding protons like tiny little Lego bits, right? If we keep adding those protons, it's one more question past this here, you won't be able to answer the other question. So yeah, atomic number is the total number of protons. What's the atomic mass? Protons and neutrons. The two things you had just told me, like 2 questions back, contribute mass to an element. Yeah, so you wouldn't be able to answer this question. Why can't it be protons? We just argued that both of them have mass, so to make something heavier, you could arguably add both. But why can't you or shouldn't you add protons? What does that change? The fundamental nature of the element itself. It becomes a different element if you add more protons to it. It's no longer boron. It's, well, whatever comes next. All right? So you have to be adding neutrons to the mix. And that gives us another word question that disappeared, isotopes. Remember the conversation about isotopes, okay? Speaking of isotopes, we depend on them in geology, environmental science. Yeah, they look at isotopes as well, but in my realm, the fact that elements decay, certain isotopes decay differently than other isotopes, is very important to saying that this fossil is X number of million years old, and archaeology uses similar carbon dating, doesn't work quite the same. But this definition, and again we talk about it in that lecture, a substance that cannot be broken down into other substances by ordinary chemical methods. What is that, by the way? Element. All right, you guys did watch the video. Good for you. I would say that radioactive decay is an incredibly natural process. So, but this remains. I looked this up years ago. A couple different. At the time, we had a. Wasn't exactly remedial chemistry, but it was close to it. It was chemistry 090, or maybe it was Chem 100. And I wanted a really basic and fundamental definition, and I looked this up there. And as I said, I had that same sort of qualm about it. But I looked at a handful of other places as well, and that was a fairly consistent and acceptable definition. So we went with it, and it served as a teaching moment as well. Two or more different elements mixed together, we call that a compound. Beautiful. In geology, mineral is a very close definition to that. A mineral is composed of one or more different elements. Some things, gold, sulfur, diamonds, are only composed of a single ingredient. So it's sort of a trick question combo for them. You guys only end up seeing the one of them. But that's why the word mineral shows up there. 14 and 15 are kind of like pluralization rules, right? Smallest unit of an element that retains the properties of the element versus the smallest unit of a compound that retains the properties of the compound. Which one is atom? Which one is molecule? Yeah. Okay, and you've been saying this your entire life without really even thinking about it. You've probably never said an atom of water, or if you did, you were like 3. Okay? It just doesn't even sound right, right? It's a water molecule, not a water atom. And similarly, well, it kind of falls apart. We say hydrogen atom. You might also hear people say hydrogen molecule, because there's those handful that always have the 2 next to it. H2N2. But definitely it doesn't sound right to say backwards, an atom of salt. No, we have a salt molecule. So, anywho. All right, 1 more, 2 more, and then we're done with that. I hate those opposite questions, the negative questions. This blah, blah, blah is not. Sometimes teachers just use them. In my case, they're being used because these evolved from fill-in questions, fill in the blanks. And I would have had something along the lines, or a short answer. Tell me everything you know about elementary particles, or something along those lines. And I was looking for, fishing around for 3 or 4 vocabulary words, right? So one way to get around that, again, without having 5 or 6 answers down here instead of just 4, is to go the negative route. And you going into elementary ed? Usually get a few teachers, proto-teachers. You'll learn at some point about the theory behind writing questions, the science behind writing questions. There actually is a bit to it, if you want to write a good question. I'm not saying all mine are good, but some of them are halfway decent, I'd like to think. But this is never a great formula. The exclusionary. At any rate, which one of these doesn't fit? Electron. Anybody else throw in there? Huh? Quark? Anybody else? Say proton. Anybody else? Well, no, I'm not saying they're wrong necessarily, but so yeah, no, those first couple of things are definitely things that elementary particles are. All right, electrons are as basic as it can get, at least as far as we know. Quarks, the same thing. Quarks are what we use to build protons and neutrons, and therefore they are both electrons and quarks, the smallest pieces of matter that exist that we currently know about and have made it into common conversation. I'm sure there's some physicists and chemists in some nooks of the world who are already arguing about the proto pieces, and of course they are, and there's Wikipedia articles about all that, but in common conversation. So the one that does not fit is proton, because protons are not elementary particles. But all the others can be true. All right, so why did we drag you through all this in the first place? This is environmental science. This doesn't have anything to do with atoms, right? Well, no, it does, of course. We're here to study the Earth and all the things that possibly could go wrong with it and have gone right with it. In order to do that, we need to understand what it is, what it's made out of, what's going on it. And that is basically going backwards and looking at the rock that it's made of, the mineral that that's made of, and those, of course, are made up of the elements. And in order to understand how the elements interact with each other, we need to go even smaller and look at their atoms. And yeah, sometimes you even need to look at how the atoms interact with one another if you want to talk about why sulfur bonds so awesomely with water vapor in the atmosphere to make acid rain. That's literally down to that level that we were just talking about. Are we doing that in here? No. But we're going to be talking about it, at least in the background. So, it fits. Arguably quite a holistic backup view, but it fits. And here we're going right into talking about elements in the atmosphere. What's number 1 in the atmosphere? Number 2? Beautiful. Why do we have an atmosphere? Oops, I accidentally highlighted it. We had a small debate this morning about how interesting it would be if air was magnetic. It would really change things, I think. A lot of them missed 21 this morning. What do you guys think? Decrease. Anyone for increase? Yeah. Okay. So again, because of the previous sentence, this stuff does build a bit. I'm learning myself here. Okay, because we just decided that the gravity is what holds the atmosphere to the surface of the Earth. Gravity is strongest when you're closest to it. The atmosphere is a lot thicker close to the Earth than it is higher up, right? And because air pressure is really just a function of that, it's the weight or the mass of that stuff pushing down on you. The less air you have above you, the less air pressure you're going to have pushing on you. And that is, we've been talking about density the whole time. So yeah, okay. The farther you go up, the less air molecules you have around you and above you, and because of that, your air pressure is lower as well. Good job. However, that is not said to be for temperature. Temperature bounces back and forth, right? It decreases as we go through the troposphere where we live, which will be a question in a moment or two. Then it goes back up in the stratosphere. Then it goes back down, I believe, in the mesosphere. And then as you go up through the thermosphere into the exosphere, it just keeps going up. And we had quite a conversation about that. So temperature varies. Which atmospheric layer do we live in? Troposphere. Beautiful. And we have a special vocabulary word for temperature change within the troposphere. Yeah. Yes, I agree. So most of these are real. Thermocline, you guys are actually going to get eventually. That talks about temperature change in water. All right. Geothermal gradient is another vocabulary word for this test. That talks about temperature change in the Earth itself. Lapse rate is temperature change in the atmosphere. So the only word I made up in this case is geothermocline. I kind of combined the two there and made up a fake word. Why do we like ozone? Yeah, UV. It gets rid of the ultraviolet radiation, and we like ozone to live where? Stratosphere. Yeah, every so often it's in the troposphere. We don't like that. We call it smog. You'd think we'd want the extra filter, right? But it tastes really bad. Ugh. like it because of that. If we still had the hole in the ozone layer, we'd probably... I wonder if smog levels went up after we closed the hole in the ozone layer. It was all just sort of siphoning out, maybe. At any rate, if we still had the hole in the ozone layer, I was thinking maybe we'd want that extra layer of protection. More cities, more smog. All right, let's go a little further out. Layers around the Earth that protect us from solar winds and other renegade cosmic radiation. Yeah, we got a twofer here. Okay, now mind you, the Van Allen belts are a function of the magnetosphere. They wouldn't be there if the magnetosphere wasn't there in the first place. But they are a nice added bonus. Okay, nice added bonus. So A and C. What's this one? Yeah, magnetosphere. Okay. We talked about how that the rotation of the Earth and the liquid core and the I think we've got the diagram of the Earth coming up. We'll talk about that in a minute. Because there were some questions about that one misbehaving. What causes the magnetosphere? Okay. And again, I don't know how much science articles, if any, you guys get in your news feed. Hopefully your news feed is something totally independent of your social media. All right, they really shouldn't go together. But there's been a lot of articles about the North Pole moving quite strangely. So I don't know that we're lining up for a pole reversal or not, but something is amiss. We know that it doesn't really affect life too much because we don't see any mass extinctions lined up with any of the previous pole reversals. There's been many. And that was my first guess, because we've got even iron in our blood, and that's charged positive, negative, just like the Earth is north and south, so on and so forth. But they don't seem to tie up to any, like I said, any mass extinctions. What it'll do to all our electronics? That's another question. We know all the migrating birds are going to be confused for a while till they figure that crap out. But, and dogs too, I guess, are very magnetic sensitive. But it doesn't seem to kill things. Knock on simulated wood grain. Changing gears yet again, this incoming solar radiation, which will be a big part of our conversation to come, again, if only indirectly, when we talk about all the different regions on the Earth where we can live and what the weather, the climate is. What causes the seasons? And I didn't highlight that on purpose, it's just where the mouse ended up. Is that even correct? No, that is not correct. Is it A or B for starters? A, okay. Yes, they get sun at the North Pole. Yes, they get sun at the South Pole, but more of the sun's energy bounces between 23.5 north and 23.5 south. That is because of C, okay? I apologize if you sort of didn't make that connection, but I did give you an option to choose A and C here. So yeah, you wouldn't have the tropics, okay, if it weren't for the fact that we're 23.5 off. Vernal, is that spring or fall? Yeah, we got autumnal and we got vernal. Which one's which? Yeah, vernal, spring, autumnal, fall. But regardless, the sun shines, same place for both of them. That is where? Yeah, equinox, equator. Again, we had a handful of folks missing that in the last class. It's got half of the word embedded in it, okay? So, doesn't matter which it is. Which one are we coming up on? We're coming up on vernal, okay, spring equinox. We've got less than a month until it's officially spring. Not that that matters too much to Utica up here. We are latitudinally challenged. But regardless, it's a mental thing. Even the beginning of March for me is just a big... one of my friends was like, but yeah, it's so the snow's gone, but everything's brown and dead and muddy. And I'm like, it ain't snow. Now, we get snow here through May sometimes. So I take what I can get. But shortest day of the year. Winter solstice. Good. Right around right around 21st of December. All right, give or take. Depends on the year sometimes. And where is the sun on that shortest day? North, south, or the middle? Yeah, remember the seasons are reversed, right? When we're having winter, they're having summer and vice versa. So the reason that is because the majority of the sun's energy is focused at 23.5 south. We get a lot less light, a lot less energy input. All right. Switching gears again. Increase in temperature as you go into the earth. See the same list of questions. I do this as well. Okay. I reuse question answer sets, so to speak. Usually you aren't going to want to use the same answer twice, unless I'm really trying to beat a dead horse, and usually I'll put those questions all in a row. All right. But spread out like this one, you already used ideally lapse rates, so don't pick it again. So we're looking for geothermal gradient here. Sorry. Brain fart. Now, I don't know about you guys, but we had a handful of folks. I only have like 9 people in my 8 o'clock class, but that really just thought 4,000 miles wasn't enough. I'd like to think 40 sounded too much. It sounds like it should be a little under. Yeah. But yeah, 4,000 miles, roughly. We might have given it to you in kilometers. I think I went through and changed it in all of the slides. But yeah, roughly speaking, 4,000 miles. I apologize for the lack of a comma there. To the center. We gave you some New York to LA analogies and so on and so forth. But yeah, I agree. It doesn't sometimes seem like that should be. You think the Earth is huge, right? It's got to be a lot bigger than that. Highest mountain, lowest valley, sea level. We have that little variance there. This one should be old hat by now. Crust mantle core, but we divide up the core. Which one's inside, which one's outside? Molten or solid? Yeah. Mantle, we're going for the silly putty. All right, we had the conversation about how it doesn't really look like lava. We talked about propane tanks. Remember, you shake a propane tank and it sounds like there's liquid inside. It doesn't just sound like it. There actually is liquid inside because it's under pressure. And, excuse me, I need to take this. All right, so this question, I got a question for you guys. That happened. Yeah. Now, did you guys see worse than this? Because I swear somebody sent me a screenshot. It's on a different laptop, though, where it was even more mangled than that. You guys saw just the 2 off to the side? Anybody see more? Because I was at first arguing, oh, well, you've got your screen too small or something, and it happened to be some computer guy. And he's like, oh, I got a 32, a 40, a 17. I put it on all different screens, and it's just, okay. I don't know why this did this. I'd like to think, again, when we're in test mode, we're not exactly the most rational thinkers. But you saw that this word comes before the blank, this word comes before the blank, this word comes before the blank. And yeah, probably this word is here and this word is there. So I'm go through these by hand, okay? And I'll take a look, see. Some people just ended up mangling this. Some people were fine up until those 2, and their brain just went, ah. So if you were doing fine, I'll give you the 2 points if you ended up getting confused on the last 2, okay? But if you're all over the place in the first place, I probably can't help you too much. So we'll go through and I'll look at those. So you might get a point or 2 back. for them, again, more so, they seem just to have a shaky grasp of this diagram in the first place. And it is a little confusing, I guess, if you're not paying 100% attention. We started with the idea that the right side is a rather traditional crust mantle core conversation, and then the left side brings in plate tectonics. We talk about the lithosphere and the asthenosphere. Now, if you forgot that aspect of the conversation, figuring out whether A or D is the crust, I suppose, could have been a little confusing. And then that would totally mess up everything else. But I did sit here and say, okay, label this. Make sure whether you had the PowerPoints in front of you or we asked you to draw the dang thing in your notes. Had I not made such a big stink about it, I could be a little more forgiving. And then if you weren't happen to be here that day, of course, you know I put the lectures up on our class site, so on and so forth. So I'm a little less full of pity if you confuse left and right side in this case. But I still feel bad. So left side is lithosphere and asthenosphere. Which one's which? Okay, A litho, B astheno. Or if you remember that again, that the lithosphere is the crust and some mantle. All right, that goes a long way towards why it's a thicker line or thicker area than just the line there on the other side where D is. Okay, so yeah, lithosphere and asthenosphere. I think part of it is, and I haven't looked again at your guys' test. I know I've said that 6 times, but I also think there's a little bit of subconscious, subliminal, whatever you want to say, going on the fact that you have the word asthenosphere and you also have an A there. And I see a lot of people put asthenosphere A just in your head. Asthenosphere A, yeah, it starts with an A. So one of these days I'll get out my photoshopping kung fu or whatever, PDF editing, and maybe I'll relabel this. So this starts with A down. Well, no, I'd have to move it over here to do my scientific experiment. But just relabel this. So neither of these has an A on it. And see if the answers, you guys get it more correct. Anywho, D is C, mantle, good. E, inner, and AB, outer, beautiful. All right, age of the solar system. Yeah, million or billion, that's sort of what it boiled down to, hopefully. Okay, and we're looking at billion. It is quite old. Okay, age of the Earth, same number. Oops. And that is, it's a question on the next page, but it makes more sense to follow right now because we believe in what theory? Solar nebula theory. Exactly. Great job. All right. Solar nebula theory tells us that we started with the ball of gas and dust, the nebula. You should probably see that vocabulary word in a moment. That condensed, and most of that energy went into the sun. Most of that matter went into the sun, leaving the riffraff around it to coalesce into planets over time. All of that did not happen with a wave of a wand in one instant, so to speak, but it was an event, a single event, again, so to speak. So we can say, roughly speaking, that everything is the same age. There is, of course, a bit of variance in there. Because of things like weathering and erosion, however, finding a rock that old on Earth is kind of difficult. It's buried. The whole needle in the haystack conversation is like seriously applies here. Luckily, because of solar nebula theory, again, we can use a hunk of asteroid. Okay? And we've tested many of those, and they come very close to the, again, exact same age. The Earth itself, we found, I think last I looked, we're right around 4.34, okay, for a rock, which is pretty dang close to 4.6. I realize we're in the realm of billions, so that's a good chunk of change nonetheless. But close enough for science, right? All right. So this one we already answered. And let's move down here. All right, so this talks about as the planets coming together. And a lot of stuff was happening here. We talked about that. That flaming ball of goo that was the Earth is cooling off. And we talked about some fundamental properties of a lot of different forms of matter. But when they get hot, they expand. When they cool, they contract. And we realize, looking out at the Earth now, that obviously the crust did cool at some point. We know because it leaks every so often that the inside did not fully cool. So we have the Earth cooling, shrinking, cracking to fit the middle that didn't cool and shrink. And while that's going on, we've got outgassing happening, which is basically volcanic activity. And from that, as such, we also have lava coming back out to the surface. All right, so A and B are correct. If you're wondering about C, that is what the sun will do at some point as it is dying. It's going to go through some contractions and expansions, eventually expanding to envelop the planets one by one. And but we'll be dead long before it actually gets to us, because as it gets closer and closer, things will change. Probably by the time it takes in Mercury, it will affect us in a very negative way. We'll probably turn into Venus or something. We'll see. Don't quote me on that. All right. Photochemical dissociation. Water molecules in the presence of sunlight breaking down. Going on all the time. But it had to start at some point, and that allowed us to build up by those free oxygens floating around in the atmosphere. It allowed us to build up, eventually, ozone, which is, again, why it's important to us. First life forms. All right. A lot of folks picking the 3.5 million. Not quite old enough. Okay, not quite old enough at all. 3.5 billion is the number we're looking for here. Now, mind you, it is a big chunk of time before we get from the very simple, relatively speaking, simple bacteria at 3.5 billion years ago till we get to the more complex structures. Okay? But our earliest views are at this time. As I indicated, it is a bacteria, not an algae. The fact that it's got the bluish-green to it is quite important. Again, a handful of questions got left off of this test. We do talk about, in some versions, we would talk about the chloroplast. Especially in here, it would have been kind of relevant because we do get to photosynthesis eventually, right? So we've been photosynthesizing for 3.5 billion years that we know of. Mitochondria are the animal version of what allows plants to do photosynthesis, energy production. Mitochondria are the organelles that do energy production for animals. We know about these blue-green bacteria because we found fossilized structures, these condos, I call them, okay, called stromatolites. It's the layer cake of algae and mud, bacteria and mud, over and over and over again. Looking very similar, but being of different color and composition, we had the BIFs, the banded iron formations. All right, and they are the source of today's iron supply. They are billions of years old, and as I said, they are banded iron formations, not biological iron formations. I don't really like trick questions, but that, I suppose, is close to a trick answer there. Biological iron is still the same acronym. And it is formed biologically. So, because remember, it was the oxygen given off by this cyanobacteria that bonded with the iron that was dissolved into the water to deposit as iron oxide. So it does have a biological origin to it. So if we hadn't done that, we might not have today's iron. This one is totally random. in the semesters when I do a little bit more in depth into cosmology, we talk about the next closest star system, which is the Centauri system. Okay, it's a triple star complex. For the longest time, we just knew about Alpha and Beta, and then as telescopes got better, we learned about Proxima, and so I talk about that for so long, and it's kind of neat, and people remember it, and they remember that Proxima is the closest of the three. So they read this again really quick, and it's the end of the test, you're toast, and so on and so forth. So a lot of people end up picking Proxima, but sillies. What's the closest star to the Earth? The Sun. Okay. Well, depends. Nowadays they say we're all a simulation, right? We're in a computer chip somewhere, but I prefer the older version of that. And even if we were in a planetarium, I mean, even if the stars are projected, if you're projected, that's still real, right? But at any rate, so yeah, the Sun, and people do miss that one. If you missed it, I apologize, but you should know that. You're 20 years old by now. The Sun is a star, okay? We don't really think about that, but it is a star, and it is the closest, coming in right around 93 million miles. Sometimes a little closer, sometimes a little farther away. But on average, we just passed either aphelion or perihelion, actually, about a month ago, which is, depending on which one it is, either the closest or the farthest from the Sun. I think we're the closest. Like in winter, we're the closest. Seems oxymoronic, but so, anywho, 93 million miles on the average. If you did miss that one, feel free to appeal with me, because technically we did not cover that. But all right, mentioned nebula should be coming up, and indeed here it is. A nebula is a cloud of gas and dust, most simply put. Okay, it is also what stars are made of. These condense and they make stars. They're also left over when a star explodes. And we went on to talk about that is how we got so many of our elements. A star itself can only make up through iron. I'm infringing on one of the next questions, I think. But yeah, there it is. Stars can only make up to iron. But we obviously have elements way beyond that. So the idea is that these supernovas allow stars, in the immense heat that they produce in their explosion, to fuse beyond iron. All right, and then as we go through subsequent stellar evolutions, if you would, cycles, nebula cycles, you're able to fuse more and more and more elements up to what we see today, 100 and some odd elements. I forget where iron is exactly, but it's not very far along the list. So, all of the above for nebula. And supernova is one way a star can die. It fuses beyond iron. And it creates nebula. So that's, again, A, B, and D. One of those, all of the above almost. Okay, now we get on to stuff that's finally unique to you guys. And I promise the rest of the semester will be just that. Environmental philosophy, whereby people want to conquer and exploit nature as quickly as possible. Frontier. Good. Good, good, good. Aptly named. That's when we first got the opportunity to do that, right? Nature and all forms of life deserve respect in and of their own value, sort of intrinsic respect. Yeah, the biocentric preservationist. Good. Biocentric, life-centered. Preservationist, obviously, a good point as well. Environmental philosophy that nature and life should be conserved because of their value to humans, not because they're cute and fuzzy. Yeah. It's a very utilitarian kind of viewpoint. So we conserve, but not necessarily entirely altruistically. First National Park. Yeah. few other things on our mind in 1772. 1972 is a little late in the game. So, yeah, 1872 seems a logical choice there. But what was the... I keep highlighting the right answer, and it totally not on purpose. Which was the first? Yeah, Yellowstone. Which president established the park system? Which? Roosevelt. Even I forget that one. All right. A little harder now. So, General Revision Act. I know we went through a whole bunch of acts, but I tried to pick some answers that really helped you narrow it down. So, establish forest reserves, establish no drill sites, no fly zones. None of those are all of the above. Think about when a lot of this stuff was being made. Mind you, we were drilling for oil, but probably not worried about flying over nesting birds back then. This is the forest reserves. Okay. Forest reserves. Antiquities. A lot of the same questions. Or a lot of the same answers, I mean. Anyone? Yeah. We lost our ABCDs, I noticed.
I just noticed that.
It's a different set of questions. And probably they never were made with it. Or I typed these in by hand when we switched over to D2L. I know they're older than D2L because the one back here had Trump in it, so that was back in the 2016 to 2020 era that this question came up. But yeah, I probably had to retype them. Use without impairment. I like my answer choices here. Which one? Which one? E. None of the above. No, we don't have any. B, okay. Let's say D, maybe. Yeah, B. Ensure that development of land would not impair its use as intended. So this came up with the Dinosaur National Park. They wanted to flood it with 300 feet of water, 400 feet of water, even if it was 100 feet of water. They successfully argued that would sort of, not really allow scientists and or tourists to go look at the dinosaur footprints without proper equipment. But I thought A was pretty good. Impaired. And this one is a particular pet peeve of mine. Just because you can get up at 8 o'clock and set up on the beach doesn't mean you need to sit in the front row with your giant cabana. It's really annoying. EPA. Good job. Almost done. Generally speaking, do you think the Clean Air and Water Acts have helped? Yeah. Seem to be, at least on the graphs I showed you. Last 10 years, like I said, that we don't have data for, at least in my PowerPoint. Assumably, we follow much of the same trends. We'll see how things go. Let's see. Based on class discussion, why do you think the condition of the Earth has become a political topic? Ooh. The last one. Let's see. So we need the help of the government to regulate sources of pollution, etc. That's true. Oftentimes, making changes towards more Earth-friendly practices costs companies large amounts of money that are hard to recover. It's also true. Special interest groups and companies often donate money to politicians. Oh boy, that's also true, unfortunately. And heads of government offices are often political appointees. The EPA, for example. So yeah, unfortunately, all of the reasons why the Earth's health is a political debate. Okay. And similar conversations going on about humans' health as well right now. Why is that a political debate? And sadly, it's all the same reasons in many cases, if not a few more. So, Yeah. Politics and science, not great bedfellows. Oh no, 61 unanswered questions. All right, so back to the point at any rate. It sounds like you guys did pretty good overall, or at least the people that were answering and participating today did well, and I'm hoping that the rest of you are just, being shy and you did well as well. If not, I'd be willing to bet that as long as you put at least the same amount of effort in, if not slightly more, the next time, that your grade should go up. Okay? If it can go up. We tend to see the bell curve oftentimes. There's a reason that exists. Okay, we get a handful of people that do really good, a handful of people that do not so good, and a whole bunch of people in the middle. We often don't see that on science tests. All right? Oftentimes you get it and you don't. Don't see a whole lot of C's. So we want it, and I'd love to see all A's. I don't care about distribution. I'd be more than thrilled to turn in nothing but A's and B's. Okay. So let's shift that bimodal Humpty back camel to just a single hump, and at least approach standard distribution of grades. But now, as I said, knowing how I write questions, knowing the level of detail that I test to, and the simple fact of when I say, hey, this is going to be on the test, that you actually make a not just a mental note of it, but a physical note, okay, in the future. So when you're going back through and studying stuff, All right, so we don't usually take an entire hour to review a test. Today was a lot of extra stuff, front-loading it with some, basically the same way I ended it by talking about how you did or didn't do. And this was a long test on top of it. Typically, we will go over every test, but then we're also going to jump into new lecture. Today, we didn't really leave ourselves enough time to go into more lecture, barely start something, and then have to wind down. So I'm going to give you guys this 15 minutes here is, time to go. I got to take attendance, of course. We are headed, it's probably worth checking, we are headed to, for those of you who like to read, taking up some of your precious 15 minutes here. I bet I didn't front load them. If only this damn guy would give a lecture schedule, huh? I want to say we jumped to chapter 3. But part of me says it might be 5. Six, 5, 3, 4, 5, 6, 4. Aquatic ecosystems. Yeah, I think we're jumping straight to 3. To see what 1 and 2 are. But 1, I'm sure, is introductory stuff, which we've obviously covered, and then some. The better question is why are we skipping chapter 2? Anyone have their lecture book on them? All right, so I'm pretty sure we're going to 3 if you want to read ahead. Your best bet would wait till Tuesday and see what we talk about, though.